Hi guys, how's it going? So I've been looking online for more difficult 1 to the infinity indeterminate examples, and I couldn't really find many, so I decided to upload one myself. So for this one, we have the limit of x going to infinity of 1 plus 5 over x to the 2x, and when you plug in infinity, 5 to the infinity goes to 0, and you're left with 1 to the infinity, which is indeterminate. So how do you solve a problem like this? So the first thing you do is you take a little equation off to the side, and you do e to the ln of some variable y is equal to, and then e to the ln of what you have that's indeterminate. And the reason you do this is so that you can bring this 2x down, because with properties of logs, you can bring your exponents down. And then this will allow us to use L'Hopital's rule and solve this indeterminate problem. So you take your limit, x goes to infinity, of 2x times the natural log of 1 plus 5 over x. And once again, the reason we can do this is because of the properties of natural logs. And then when you have this, it'd be a little easier to write it as so that you can have something over something. It's the same as lim x to the infinity of 2 times the natural log of 1 plus 5 over x all over 1 over x. And now, when you plug in your infinity, this will go to the natural log of 1, which if you look at the natural log of 1 graph, that's undefined, and it makes it it's a 0. And then 1 over x also approaches 0. So here you have 0 over 0, which is fantastic. We can finally use our L'Hopital's. So when we use our L'Hopital's, we get from x going to infinity, we'll still pull our 2 out here, and we have 1 over 1 plus 5 over x times a 5, and with our chain rule, it's multiplied, sorry if this is a little confusing, but it's multiplied a negative 1 over x squared, and all of that is over a negative 1 over x squared. And now if we mix some stuff around, our negatives, as you notice, will cross, and we'll multiply our 2 and our 5, and we'll have our 10 out front. And then we will pull this x squared to the top, because a 1 over x squared, the x squared's on the top. 1 over 1 plus 5x, we'll just put that on the bottom, make things easier. Plus 5. And then we have this x squared on the bottom. And now things have gotten really nice. We can cross our 2x squareds. So I'll go over to the next page and do it. I'll leave myself a little bit more space. So all we're left with is 10. I'll pull it to the outside of my limit. And then over here we have 1 over 1 plus 5 over x. And we have pretty much made it. You take this limit, this goes off to 0, you're left with 1 in here. So in general, you're left with 10. All done? No, 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 no. So remember, over here, when we set up this equation, we set it up to be e to this, and then this is what we were doing all our stuff to. So now here we are at the end. We need to make sure that we plug it back in. So we plug it back in. We have e to the 10th. And then that is our final answer.